Welcome, everybody. Happy Monday, the best night of the week. Welcome back to another RfRx. I'm Kara Griffin. I'll be your host this evening, and I have with us our trusty co-host, Rob Palmer. Rob, how are you doing?
I'm doing just great. I'm so looking forward to this.
Me too. I am so excited for this week. I have been excited about this. So we'll start jumping in here in just a second. But before we do, we want to hear from all of you fine people out there about your thoughts on this topic before we hear from guests. And let's go ahead and launch our first poll. And I'll go ahead and read the questions off. So people can hear the audible version as well as you answer those. So the first question is, have you heard of the theory of intelligent design? And the answer choices are yes, no, or not sure. The second question is intelligent design A, a form of biblical creationism, B, a scientific theory arrived at through research and exploration by religious scientists as an alternative to evolution, C, a hypothesis that we're all living in a complex simulation, or D, I don't know. And then finally, we have another question. Is intelligent design a scientific idea supported by many professional scientists? And the answer choices are yes, no, I don't know, or who cares? So we'll leave that up for a little bit for you all to answer and give us your thoughts on it. And then we'll get going.
I love that theory was in quotes there, scare quotes.
Yes, scare quotes. Yes, we do not play fast and loose with our scientific terms here. But I imagine we'll get into some discussion of that later on this evening. What do you think?
Sounds like it makes sense. Yeah, like a lot of words, they have multiple definitions, and theory is certainly thrown out. I have a theory that I left my suitcase in the car. It's not the same when you use that word in a scientific context.
Absolutely. And I'm guilty of that too. And I will get on to people for using it incorrectly. And then at the same time, I'll use it in the colloquial sense,
Yep. It's hard not to do. It has multiple meanings.
It does. English is difficult. It's a confusing language. So we'll unpack some of that later, I bet. So I guess, what do you say we talk to some people about what we're doing here? What is RfRx, Rob?
Yes. Well, RfRx is what we call our weekly meetings, and that's where we host guests who discuss topics relevant to the folks in this community. Right? It's not a replacement for the online community or our support groups, which you'll hear about later. But these talks and presentations aim to provide really good information, advice, coping skills, etc. for our clients and our community. And you can send any pertinent questions or comments and inquiries about this talk or anything else to the address that's in chat, which is rfrx@recoveringfromreligion.org. And by the way, we record all of these and we put them in two places. One is on YouTube. There are 94 entries up there, and even more, because it's easier to edit audio, there's even more on our audio podcast. But I keep using the word RfR. What is that? What does that mean, Cara?
Great question. I'm glad you asked. For any people that are new to the show, let me tell you, it stands for Recovering from Religion. And our mission statement here at Recovering from Religion is to offer hope, healing, and support to those who are struggling with issues of doubt and non-belief. And we do that in three ways, as I just said, through hope, healing, and support. So Rob, do you want to tell us a little bit about healing?
Yeah, healing is composed of our 24/7 support, either chat or phone lines, and you can reach us from anywhere. You can even schedule a call at a convenient time. And you'll reach volunteers like me who offer empathetic support without judgment or criticism. And we also suggest resources, and those are also directly available via our really greatly redesigned, fantastic resource page at recoveringfromreligion.org/resources.
And I am going to post that in the chat as well. There you go.
That's the first part, the healing. And then there's also hope and support. You want to tell us about those, Cara?
I would love to. So hope is something that we try and offer through providing places for people to share and listen to personal stories. And we do that with our blog and our podcast. And the idea behind that is just to kind of build that sense that we are all in this together, and we may all be going through different kinds of things, and we all have our own story and our own experiences. But maybe we can gain some inspiration or some hope from hearing about someone else's journey, and taking something away from that and having that sense of sharing that together. So those are both great places to check out those stories and hear more about other people's experiences. And in a similar vein, support, we offer support in a few different ways. The first way is through our peer support groups. And these are face-to-face meetings. Prior to COVID, they were all in person, but during COVID, we switched over and started having them virtually, and many of them are still virtual. Some of them are transitioning back to having in-person meetings also, I believe, but for the most part, you can find all of these face-to-face meetings with the peer support groups online. And we have more than 60 of those going on around the world, and we're continuously starting more wherever we find a need. And so you can actually find the nearest one to you by checking it out on Meetup. And I'm going to pop that in the chat too. And the great thing about it being virtual is that you don't actually have to go to the support group that is nearest to you. You are certainly welcome to find the one that's nearest to your city or town or state or country, but you don't have to join that one. It's perfectly okay if you find one that meets at a more convenient time that is nowhere near where you live, and you can go to that one. There's not like a residency requirement or anything like that. You're perfectly welcome at whichever one is convenient for you. And I do want to mention, we have just recently started a brand new virtual support group chapter that is specifically for our LGBTQA plus members. And that support group meets on the third Sunday of each month at 7 p.m. Central Time. And again, you don't have to live in Central Time Zone to join that one. I'm going to drop the link in the chat for that as well. So if that sounds like something that you would be interested in joining, please feel free to check that out.
And if you need support beyond peer-to-peer support, we have the Secular Therapy Project, which has 580 plus therapists at this time. And it's supported over 28,000 clients since its inception. So this allows clients to connect with a licensed secular mental health care provider. And the therapists are carefully screened for several criteria. They need, of course, to be appropriately licensed in their state or country. And they need to maintain a secular practice, no religious proselytizing, and they exclusively use evidence-based treatments.
Absolutely. And let me drop the link as well for that in the chat. Be sure and check that out. And we have more support to offer as well. Another place you can find that is in the online community. And that is a platform that we use online. Again, it's a community that is not just open to the public. You do have to join it in order so we can make sure that there aren't trolls or anything like that getting in. So it is a semi-private community. The way you could join that is if you call or chat into our helpline and speak to one of our agents. They'll ask you a few questions, see if it seems like you might be a good candidate, and they can get you plugged in to the online community. They'll send you an email and you can join. And there are all sorts of groups within the online community that you can join through different channels in it. And they're sort of directed at different people's experiences and backgrounds. Like maybe you are a former Jehovah's Witness or a former Southern Baptist, or you're currently or previously were in the military, or you're a member of the LGBTQ plus community, or you're dealing with parenting issues in a relationship with one person who's religious and one person who's secular. Whatever your life circumstances may be, there may be another channel in our online community with other people who are going through similar things, and you can connect with them and talk about those issues that may be relevant to you and sort of build that community and share with them. So we also, in addition to that, have weekly Zoom meetings, usually on Fridays and Sundays. So maybe you're looking for a group of community to get together with on a regular basis that isn't a religious community or something like that. You may be able to find that here. So again, like I said, if that's something that sounds like it might be for you, go ahead and just contact our helpline agents through the chat or on the phone, and they'll get you set up. And I also want to give a shout out to the wonderful and amazing atheist community of Discord. As I mentioned earlier, we are currently streaming to the Discord, which is a super cool place to also meet other people. That's a place for people who are openly atheist and public about that. So some people may or may not be comfortable doing that. That's okay. But if you are, and that's you, and you want to meet some fantastic and exciting and interesting people over there, jump on to Discord and find them. And I'll drop that link here in the chat too. Finally, Rob, do you want to talk a little bit about volunteering?
Yes, certainly. So RfR volunteers can find meaning and purpose by volunteering with us, right? We're always in need of volunteers, and there's all sorts of jobs besides working the helplines. I first contacted RfR, and that's where I started. And after that, I just got involved with pretty much everything. And there's always spots for people, whether you're doing IT support, the stuff that we're doing on here now, people who do video editing, people who want to research information to be put in our resources. There's so many different ways you can help us besides direct contact, but we also love people who can do that. So yes, we're going to put up the link for the direct path to the volunteer page. There's a little instructions there and a form you can fill out and tell us what you'd like to do. And I actually interview people who do it. So you might get me on the phone if you interview for volunteer position.
Yes, Rob actually trained me.
And I train people, yes.
Yeah, absolutely. All right, well, that is excellent. Thank you for sharing that. We're looking forward to getting some more volunteers possibly. So let's actually get into it tonight. The reason we're all here, what are we doing? Okay, let me give you the layout. The format of the show is that we're gonna have a discussion with our super amazing guests that I'm so excited about for about an hour. And then after that, we'll do Q&A for maybe 20 minutes or so. But in order for us to do Q&A, we need some questions. So if you have a question while our guest is speaking, feel free to type it into the chat and preface it with the word question. So our chat monitors and Rob and I can tell that it's a question for the guest, and we'll be collecting those throughout the presentation. And then when we get to the end, we'll ask some of them. We can't always promise that we'll get to all of the questions. A lot of times we get a lot of really good questions. So we'll get to as many as we can. But after that, we'll have some closing thoughts from Dr. Darrel Ray, our amazing and fantastic founder and president. And then we'll move into the social hangout time where we turn off the recording and allow all of you wonderful people to unmute yourselves and continue the conversation and chat and talk about whatever issues may have come to your minds during the talk. So I cannot wait to get started. Rob, do you want to introduce the guest?
Oh, I certainly will. So yes, actually, Dr. Lentz came to my attention when I attended the last live PsyCon, and he gave a fantastic presentation. And we're going to hear a little bit about that topic tonight. So Nathan H. Lynch, Ph.D. is a professor of biology and director of the Cell and Molecular Biology program at John Jay College and the City University of New York. He's also a visiting professor of forensic science at the University of Lincoln in the UK, and an elected fellow of the Committee for Skeptical Inquiry. Dr. Lentz's research explores the evolution of the human genome and the genetics of human uniqueness. He's published over 40 research articles and book chapters, and his work has been funded by the National Institutes of Health, the National Science Foundation, and the US Department of Education. Professor Lentz is also a very busy science writer. He blogs for Psychology Today and maintains the Human Evolution blog, and his musings on human origins have appeared in this Science, the Wall Street Journal, the Huffington Post, the Guardian, the Observer, Skeptic Magazine, and my favorite magazine, The Skeptical Inquirer, as well as others. He's also the author of two popular science books, Not So Different, Finding Human Nature in Animals, and Human Errors, a panorama of our glitches from pointless bones to broken genes. Okay, take it away, Dr. Lentz.
Okay, well, thanks very much for the invitation. I didn't know about this group, but I'm glad I do now. And I hope I can, make some friends and connections here. It's always nice to meet the growing secular community that we have. And I'm going to now share my screen, pardon me, so that you can see my presentation. And I'm going to ask somebody to confirm that it worked correctly. All right, we'll do that. And now we're going to full screen it. Okay, how's that?
That's good.
Looks good.
Okay, great. All right, great. So I titled this talk, Intelligent Design, How Creationism Evolves, just to sort of put our thumb in their eyes a little bit. But I want to tell you the story about how this came about and how my interest in intelligent design. But I'm gonna start at the beginning, which is what is intelligent design and where it comes from. Before we get any further, though, one thing I want to recognize is that I'm a part of this group called Peaceful Science, which is not exactly similar to the goals of this group, but this is a group that of scientists, a lot of secular scientists, but also Christian and other religious scientists who have made it their mission to try to help people who are people of faith to come to terms with evolution, with the reality of biological evolution on our planet. And so it's not quite the same as this group, but there's a lot of overlap in terms of interest. And so I've been reaching out to communities of faith around evolution education. And I've been pleasantly surprised that I think we're very much at a turning point. From what I can tell, there's major evangelical leaders that are sort of starting to drop their resistance to evolution by natural selection. So that's of the many fronts that we can fight on the pernicious role of religion in politics. I think I've been kept in this one corner of evolution for a while, but I'm glad to see that we're actually making a lot of progress there, and some of it we'll be talking about tonight. Okay. And I say this, I mentioned this to you because a lot of people who have come away from religion still have families that are, well, most of their families are still very much a part of that. And you might never be able to lead them away from some of that. But what you might be able to do is at least attack the science denialism and the other things that are attached to science skepticism. And that's what peaceful science is all about. It's not about trying to convince people to leave religion, but rather to find ways to make it compatible with what they need to believe. Or I should say, to make the religion compatible with the reality that science has been revealing to us. Okay, so without further ado, let me start introducing you to the concept of intelligent design, especially for those who may not be familiar with it. Oops, that should have worked, but didn't. There we go. Okay, great. So the intelligent design movement is it's relatively young. Form of creationism, but it's based on a very old idea. There's a philosopher and theologian named William Paley in the 1700s who articulated, picking up on Thomas Aquinas, articulated the idea that the existence of all this complexity in nature speaks to some kind of designer or creator. Before, even Richard Dawkins has said, before we really understood the mechanisms of evolution, it was sort of hard to argue that there's all this complexity and it had to come from somewhere. And William Paley, of course, was working before On the Origin of Species came out. But of course, those of you who are aware of this ancient battle that we've had, Hume, the philosopher Hume, the Scottish philosopher Hume, actually gave an excellent takedown of the theory of intelligent design before it was called that, even before Darwin. So if you were able to dismantle intelligent design even before we knew about evolution by natural selection, well, that's pretty impressive indeed. So any of you who want to read Hume, I encourage you. Anyway, okay, so the first time that the modern creationist movement used this term intelligent design was actually in 1989 when the textbook called Of Pandas and People. And I'm going to talk about the background of this textbook in a little bit. And I'm just going to mention some of the players here: Percival Davis, Dean Kenyon, William Dembski, Jonathan Wells, and the editor, Charles Thaxton. They're going to come up again in a little bit. So I'm just putting their names on there now. And this is the cover of the textbook. Oh, by the way, can you see my cursor if I move it around like this? Okay, great. So I can use it like a pointer. So honestly, the godfather of the intelligent design movement, and that should say godfather, not father, and he called himself that. His name is Philip Johnson, who was actually a lawyer at University of California at Berkeley. And he wrote a book called Darwin on Trial in 1991. So this was all happening around the same time. And he founded, well, he was one of the founding members, it's more philosophically than in terms of logistics, but he was there, of the Discovery Institute is in 1990. And the Discovery Institute, for all intents and purposes, is intelligent design. It is the structure, the institution, the organization that gives life to this idea. Every major figure in the movement of intelligent design is associated with Discovery Institute, if not as an official fellow, a frequent guest, or whatever. So they're all sort of tied to this institute. And that becomes important too, to understand how they work. It's not something I appreciated when they first came at me. And I wish I had. They also run this website called Evolution News and Science Today, which I want to be very blunt here and say that that is an Orwellian title if there ever was one. It is a website designed to attack the science that's done around evolution, but it presents itself as a science website when it is definitely not that. It is a critical website, but that goes into all kinds of other issues besides evolution, of course, but evolution is their preferred target. So if you ever come across this website or somebody links you, just remember, this is not a science website. This is a website run by the Discovery Institute for the express purpose of misleading people about the science of evolution. Intelligent design is not science. It is Christian evangelical creationism. I need to be very clear about that. And I have legal backup in saying that. No lawyers can come and arrest me or threaten me. And I'm going to show you why that's true in a second. But this is actually a legal finding found by Judge Jones that said intelligent design is not science. So we're on sound legal ground to say that. So the background of intelligent design really began with what's called the Fourth Great Reawakening, which was when the evangelicals started to come out of their political slumber and fundamentalists and become much more active in politics. It began with Billy Graham and these kinds of characters in the 1960s. And one of their goals was to get creation science taught in public schools. And so they started to do this. And essentially, they just got defeated in court over and over again in Louisiana and in Arkansas. And eventually, these cases were combined in 1987 into the Edwards case in front of the Supreme Court. The Supreme Court outlawed requirements to teach creationism. I want to be clear about that. They did not outlaw creationism, the teaching of creation. They outlawed requirements to teach creationism. And the reason why the case was formulated that way is that no science teachers wanted to teach creationism. And what was happening is school boards and other local politics was at play in trying to force creationism into science classrooms where it wasn't particularly welcome. And so that's why the legal challenge was as such. But however, there was a decision by Judge Brennan, or by Justice Brennan, a sentence in his decision that really opened the door for all of this. I don't think he did this on purpose, but he made this quote that says, teaching a variety of scientific theories about the origins of humankind might be validly done if there's the secular intent. And so essentially what all of the creationists did was they saw this as an opening to retool their idea and take out all of the religion and just offer it, pretend that it's science. And that's exactly what they did. And so creation science evolved into intelligent design. I often say this was the selective pressure that caused the adaptation that creation science then take on during its evolution. And you can see the evolution of creation science by looking at the textbook of Pandas and People. So there was the first draft of this book had a different title. It was called Creation Biology, and that was in 1983. The second draft was Biology and Creation in 1985. Well, the Supreme Court decisions came out in 1987. So before this book was ever released, they changed the title, taking the word creation out wisely in their part, to call it Biology and Origin. And then for reasons I'm not quite sure why this title was taken off, but I do understand why they ended up with Pandas and People. But one thing that happened between these two drafts really captures what was going on in the movement at that time. Over 150 instances of the word creation was simply swapped out to intelligent design. And creationists was replaced with proponents of intelligent design and so forth. And that's just all they did was they did a lookup and replace function with Microsoft Word. And they did it so sloppily that it introduced typographical errors. And here's an example. Creation means that various forms of life began abruptly. But that was changed to intelligent design means that various forms of life began abruptly. 150 of these instances were found throughout the book, including, as I said, making some grammar mistakes. So in the second draft, it said evolutionists think the former is correct, creationists accept the latter. Well, that was changed to evolutionists think the former is correct and design proponentists accept the latter. So it was just a poor search and replace function that showed how little effort.
Golden.
How little effort was put into this masking of creation science as intelligent design.
All they had to do was run it through a final, spell check, and they didn't even push that button.
Well, at this time, they weren't incredibly well funded. Remember, this is before the Discovery Institute was officially founded. So that was 1990. So they're working with a shoestring budget at this point. I'll talk about who was running the book in a second. Then the fourth edition comes out called Of Pandas and People. And this was the first edition to be published. We have access to these drafts, but this was the first one to be published in 1989. The second edition came out a few years later, and this is where Michael Behe, who I'll be talking a lot about later on, first appears in the intelligent design community, 1993. He wrote a chapter on the blood clotting cascade, which he still maintains is intelligently designed. Then we have the Kitzmiller decision. So this was, you guys will remember, in Dover, Pennsylvania, the school board there had voted to, again, basically put a disclaimer in the textbook that says not everybody believes in evolution. A lot of scientists believe in something like this. And it was a way for the school board, again, to try to force the teachers who were not at all willing to be teaching intelligent design. Well, this went in front of a federal judge, John Jones III, a George W. Bush appointee. And he found in 2005, in no uncertain terms, we have addressed the seminal question of whether ID is science. We have concluded that it is not. ID cannot uncouple itself from its creationist and thus religious antecedents. The trial transcripts and other materials that we used at trial are really kind of a breathtaking takedown of the formation of intelligent design. They were completely overwhelmed by the scientific community who really stepped up. Kenneth Miller on the science side, but Eugenie, what's her last name? Eugenie, somebody help me here. Glenn Branch and
Eugenie Scott.
Eugenie Scott, yes, were absolutely essential as well in this takedown at the case. I will say that this case was not appealed. They chose not to appeal, and at some point they might. So the legal battles aren't over for good. And of course, with everything we know that's ascendant right now, it's a little concerning. But anyway, in 2005, Judge Jones found that ID was not science. So they renamed the book again, I think just to get out of the baggage of Pandas and People, and they call it The Design of Life. But this time they're not pretending to be anybody else anymore, and it was published by the Discovery Institute Press, which is their in-house vanity press. Okay, the Discovery Institute, again, is a political Christianity group. It is not a science organization. It was never founded as such. Evolution is in their crosshairs, but it's absolutely a form of political Christianity. And if you look at some of the things that Philip Johnson said about the Institute, about intelligent design, you'll see they weren't hiding, or at least they were hiding in plain sight, the fact that they absolutely had religious motivations, that they were trying to bring the society into a better concert with their Christian belief, and so on and so forth. If you don't think that only good thinking will lead you back to the church, and so on and so forth, and of course their church specifically, this last quote really captures it. That's what America stands for, something we stand for. He's talking about the DI, and that's something the Christian church and the Christian gospel stand for, which is the truth of Jesus Christ and so forth. And they're going to recapture that while they're recapturing America. So this was a very much a political organization that took on evolution as their plank. And the last quote, which I think we will all agree, actually, Philip Johnson said, this isn't really and never has been a debate about science. It's about religion and philosophy. And on that point, as I said, I think we all agree. So the Discovery Institute was formed in 1990 as the intellectual home of intelligent design movement. A major figure was Philip Johnson. He has a law degree and a BA in English, not exactly the kind of credentials you would expect in someone taking on evolution, a major critic of evolutionary theory. The early founders of the Discovery Institute, you'll also see a lot of degrees here: chemistry, history of science, information technology, biophysics. But if you look at Dean Kenyon, one of the authors of the book, he did a year at a seminary. He testified as a young earth creationist in both Arkansas and in Louisiana. These are all young earth creationists. David Berlinski, Paul Nelson, these are all people who have a lot of degrees, but almost none of them in science, and absolutely none of them in biology, which is the field in which evolution is housed. So this is not exactly a powerhouse of science that we're talking about. Now, a few credentialed biologists start to appear a little bit later in the movement. Dembski is one of them. Once again, not really in biology, but mathematics and so forth. But his faculty position was at a seminary, which is not, again, where you would expect a lot of scientific research to take place. Jonathan Wells does have a Ph.D. in molecular biology. It's important to remember he got that later as he was trying to develop some bona fides in his CV. His first PhD is in religious studies, and he's an expert on the marriage ceremony of the Unification Church. If anyone's familiar with that marriage ceremony, Reverend Sun Myung Moon, the large marriages were group marriages of people who just met and so forth. It's interesting. Anyway, that's one of his areas of expertise. So just to be clear, and as late as 1991, we're not talking about 82 or 83, Wells and Johnson signed a letter doubting that AIDS is caused by HIV. This is how right-wing and conspiratorial this organization has always been. Okay, so what intelligent design is a political form of creationism. And if you look at the first textbook, the original publisher was the Foundation for Thought and Ethics, which is incorporated in Texas. In their articles of incorporation, you will find it was founded by a Baptist minister. It's described in the IRS documents as a Christian think tank. This is who's writing a science textbook, and their stated purpose was proclaiming and publishing the Bible, basically the gospel. Percival Davis, one of the authors of the original textbook, said under oath, of course my motives were religious. There's no question about it. You don't have to ask these guys very many questions before they start to tell on themselves. And then eventually was leaked one of their strategy documents called the Wedge document. It's not very long. If you have a minute, I encourage you to just Google Wedge document and you'll find it. And you will see an entire manifesto of recreating American society in line with biblical values. There is a bit in there about evolution and Darwin, but mostly it's all about replacing materialism and secular science with the gospel, with Christianity. And that's what they've always been about. Ann Coulter, if you know, is one of the most unpleasant right-wing figures in this country, was tutored on intelligent design by three people who are dominant figures in the movement, and Michael Behe is one I'll talk about today. And as I said, they run this website, Evolution News, which really pretends to be a science website when it is anything but. And in fact, if you go on to Evolution News, you'll find articles about abortion, euthanasia, marriage, and communism and Marxism is just a frequent boogeyman for this evolution website. Just to show you some of the headlines, if you scroll through, talking about abortion, we're talking about gay marriage, just all sorts of euthanasia because of laws that were going on. It's incorporated in Seattle, and that's where most of the figures live. So when Washington State was looking at assisted suicide, that featured prominently on their Evolution News website. And again, they often come out and just tell us who they are, where they talk about when science is lost because it's lost its spiritual foundations. Pardon me. Okay, so how did I get into this? How was I ever involved in this? I'm a scientist. I'm doing my work like thousands of others. And how did I get enlisted into this fight? Well, so my first book came out in 2016, and it was called Not So Different: Finding Human Natures in Animals. It's kind of a comparative human-animal behavior book. Just kind of what can we learn about why we behave that we do by looking at animal studies. Kind of a review book, almost like science journalism for all the interesting stuff going out there that I thought the public might be interested in. Well, Ken Ham didn't like this book very much, although he didn't read it. He didn't even pretend to read it. He was reacting to a press release about the book, oddly enough, and so he wrote a little something. But I thought, well, I'll play ball. So I wrote back, and I answered each one of his points with with what I talk about in the book, different data and evidence about this. And I tried to keep it cordial and nice. I wasn't trying to get into any fights, but he didn't answer back. Like that was the end of it. I didn't hear anything back, and that's sort of what I expected. Nothing really surprising there. Ken Ham, I'm sure, doesn't know who I am, and I wish I didn't know who he was. So, by the way, those of you who don't know who Ken Ham is, he runs the Ark Experience and the Creation Museum in that Louisville, Cincinnati area of the country. And unfortunately, he has a huge budget for his escapades. Okay, so my introduction to the Discovery Institute was with my next book. So this book came out in 2018, which is ostensibly about design flaws in the human body. And I want to be clear that I did not write it to attack intelligent design, because I was barely aware that intelligent design was a thing while I was writing this book. And I mean, I had heard of it, of course, but I didn't think it, and also I didn't think they would read it. I don't think they would be interested. They might shrug it off, laugh and move on. I had no idea that they would be interested. But they did. They read it and they were very unhappy. And so even about a month before the book came out, again, I guess reacting sorry. So first, I wrote a op-ed in the Wall Street Journal. I was invited to write about my book for the Wall Street Journal. So I gave a little primer of the book about 6 weeks before it came out. Well, this got the attention of Evolution News. So that's the website run by Intelligent Design. And this guy called Steve Laufman, who I've never heard of before and haven't heard from since, wrote an article and then appeared on a podcast going through all of the issues that he had in my article. He didn't read the book, right? He just read an article about the book, but that's fine. So once again, I rebutted his points. And the theme of my rebuttal was, well, if you read the book, you would see that, he was talking about design limitations. And I'm like, yeah, that's what I'm talking about too. Like a lot of what he was talking about is what the book's actually about. And as I said, I wasn't writing it as a rebuttal to Intelligent Design. I would have written a very, very different book. I'm writing to people who I assume accept evolution. Well, now you're going to see how the DI works. This is what the Discovery Institute works when there's something that comes out that they feel threatened by for whatever reason. They started writing article after article after article after article after article about my book, about me personally, about articles I'd written. They just started going through it, and they squirt squid ink everywhere they can, just kind of overwhelming the Google search results. If you Google my name, half the results are now on their webpage. They were really just going after me with everything they had, knowing that I have a day job. I don't have that much time to devote to. And most of them were just all over the place anyway. There wasn't anything coherent to respond to in most of the cases. So, in fact, this is my favorite moment. This is their website, a screenshot. At one point, I had all 3 of the featured articles on their website were about me. I felt pretty good about that.
Oh, that's fantastic.
I've never had anything like that before.
I wonder how many of your books were sold to people visiting this new site. They're making you money, right?
Quite a bit. And in fact, my agent, whenever the first article started to come out, my agent's like, "This is good. This is what you want." And actually, the way that it worked, I don't think these people are buying my books. But what happens is the other people that watch them started to see this and like, "Oh, let me go read this book." So the other kind of evolution defenders in the public space, started to see this. So I think that it did make a very big difference. I'm sure I sold a lot more books. So that's why I say, as long as they spell my name right, I'm very happy to play this game. Okay, so now let's talk about Michael Behe. So he's one of the few really credentialed scientists in the movement. He has a Ph.D. in biochemistry. He's a tenured professor at Lehigh University, which is over here in the Lehigh Valley in Pennsylvania, like just a couple hours away. And he published in 1996 a book called Darwin's Black Box, where he introduces this concept called irreducible complexity, which is the idea that living systems often have complicated systems that are so complex and have so many moving parts. If you remove any one of the parts, it doesn't function. So therefore, there's no way it could have evolved piecewise, since you need all the parts to be in place in order to function. So he offered this as a criticism. And you have to remember, the scientific community was like, that's not at all how evolution works. So it doesn't add parts one at a time neatly. The whole thing would form as a unit, would evolve as a unit, and it gathers increasingly complexity over the millennia. So it was a little strange to the scientific community how popular this book got in creationist circles, because they thought it made so much sense. Well, this book has been roundly debunked and attacked. It did actually inspire a little bit of better theoretical grounding with some molecular evolution. It was you can think of it as a contribution to science charitably. It did kind of galvanize people to talk about molecular evolution to the public better. So it did inspire some good evolutionary defense, we'll say. His own university very quickly put out a statement that is still on their website today. The homepage of the biology department at Lehigh University has a sort of disclaimer just to remind people that he doesn't speak for the college or the department, or that he's really an outlier, and he's the sole dissenter and so forth. By the way, his position's quite nuanced, actually. He's not a young earth creationist by any means, but we'll talk about that in a second. Anyway. So why am I telling you about him? Well, in 2007, he published a new book called The Edge of Evolution, where he attempted to put mathematical probabilities on evolutionary transitions. He's basically saying, okay, we can accept microevolution, little tinkering, but large-scale transitions, evolution could never actually accomplish. This book didn't pick up much more traction. In 2019, however, he tried again with his third book called Darwin Devolves, and this is where the story is going to really pick up steam. So he doubles down on what he was claiming in The Edge of Evolution by saying that microevolution, which is just generation to generation changes, imperceptible changes in DNA or proteins, from one generation to the next. Well, he was saying that that works almost entirely through destructive mutations, not creative or innovative mutations, but just basically by destroying things. One thing he kept saying is evolution just breaks things. And occasionally, when you break things or destroy things, it can be advantageous to the organism. And that's true. That's something we've long known. Sometimes actually breaking a gene makes the organism better off because that gene's not really helpful anymore or whatever. It simply holds them back. And I'll give you one example where it's definitely true that he discusses in his book. But he makes this line that evolution just kind of dirties things up and makes things worse over time. To do anything new, to create new information in living systems, you need an influx of new information from the designer, whatever that is. And he allows for at least two possibilities. Maybe it was all there in the genome to start with, and it just takes time to appear. Sometimes they call that the perfect pool shot, where over time everything ends up in the right place. He allows for that possibility, or the other possibility that the designers, of course, adding new information to the genomes in order to create new kinds of animals. So primates came into existence because the designer gave new information in the genome. Just so you know, I'm a genome scientist. I study the evolution of the human genome. Either of those possibilities would leave a lot of evidence to be found in genomes, and we've sequenced hundreds of thousands of different species genomes now. We haven't found any evidence of any of that. What we have found is a whole lot of junk, but that's a story for another day. So let's go back to irreducible complexity, because it comes up in this, and this is the notion that complexity can't come by stepwise because you don't have any advantage until you're fully formed. But that's just not true. Behe claims that for a biochemical structure to all appear in one fell swoop would be very unlikely. Yes, it would, but that's not how evolution works. And some of the reasons why this is false. First of all, complexity evolves gradually from simplicity. If you look at the vertebrate eye, for example, right, a fully formed lens wasn't added, right, in a fully formed retina. Each one of these structures gradually evolved from just simply a pigmented patch of skin that slowly became invaginated and got more complex, and you got directionality in your vision. We know a little bit, well, actually, we know quite a bit about the evolution of the eye. And also remember that the functions of a complex system evolve over time as well. And so when it's originally on its path, a certain structure isn't thinking ahead, right? So feathers did not evolve for flight. That's one thing with birds and dinosaurs that are feathered. They originally were for thermal regulation, and then they get kind of adapted in a different way. So all of the scientific examples have been debunked or still being debunked, but he still repeats them as if they're unchallenged. In the opening chapter of Darwin Devolves, he offers several examples that we have completely debunked. And I don't understand how he doesn't see that. But for example, the blood clotting cascade, which he still claims is irreducibly complex. Actually, Kenneth Miller provided a very stepwise process for how it could have evolved. And Russell Doolittle, who worked on this as well, discovered a gene for fibrinogen, which is the main clotting factor that actually exists in starfish and that don't have a blood clotting cascade. So it was evolved for this new function, and then it became more and more stepwise. Also, the proteases in that blood clotting cascade are obviously the result of gene duplications, and we've seen how that happens. There really is not anything missing in our knowledge of how this could have evolved and how this very likely did evolve, but he still offers it up as unchallenged. This is how he called it, unchallenged. And then he did the same thing for the bacterial flagellum, and that one's been debunked as well. The vertebrate eye, he offers all these examples as if we don't know how they evolved, when we actually have very good ideas of a probabilistic way that they could have evolved.
Of all the things that creationists do that piss me off, frankly, when I watch them, is after you've seen a video where they are told some fact and you know they heard it, then there's a later video with them talking like they never heard that. And this is just one example of that. It happens all the time. Yeah. There are no intermediate, species. There's no transitional fossils. Oh, how about this or this and this? Yeah. Then they make a video the next week. There are no transitional fossils.
Yeah.
How do you explain that?
Right. I mean, it's hard. I always try not to put dishonest motivations onto people. if I don't know for sure. So I have to assume they're just really convinced of what they believe. And like Michael Behe, he for all intents, I mean, by all accounts, he seems to be a nice guy. He's, fairly soft-spoken. I think he just really believes it. I don't know what else to say, especially with the way that the blood clotting cascade in particular has been debunked. I can't wrap my brain around how he believes that, but he must. Anyway, this book comes out in 2019. And it's really, I mean, it's even just a funny title. I'm going to talk about Darwin devolved, the word devolves later, but even the subtitle, The New Science About DNA That Challenges Evolution. I mean, scientists don't talk like that. I really don't know who wrote that. And it probably wasn't him, because I've published enough books to know that you don't get to name your book. The publisher does that. But yeah. Well, anyway, who would publish this book? Just so we're clear, it is not peer reviewed. It is doesn't come from a scientific press. It is published by Harper One, which is the imprint of Harper that is devoted to self-help and what's the word I was looking for? There's some money shot in there. Spirituality, health, religion, social change, relationships. You won't see, this is not a science publisher even. So this is not from a scientific press. It's not peer reviewed. Anyway, okay. So let's talk about this book. The main thesis is that random mutations, which scientists say that the main engine of biological creativity is through mutation. His idea is that mutation can only break things, and that yes, when you do break things, sometimes it helps the organism. And then natural selection operates by the survival of organisms that have these destructive but helpful mutations. And he calls this the first rule of adaptive evolution, which others have renamed Behe's first rule. And tons of evolutionary biologists are furious with this because, wait, you can't start naming things for someone that we've known for 100 years, because harmful mutation or destructive mutations being advantageous is nothing new. It's at all. So he's both exaggerated and unoriginal with this adaptive rule. So he sees that the overall trend is mutation degrades, and you need new information to do anything other than small tweaks. And a key corollary of this is he says that Darwinian evolution can diversify organisms into species and genera, that's the plural of genus, but not anything more than that. Maybe family, but not anything more than that. Anything larger scale transitions like primates or mammals, that had to have come about not by unguided processes, but by a guided process. So he sees two options, and I said this already. All the information is somehow preloaded, or you have regular influx of new genetic information. Neither one of those is there any evidence for. He does not offer evidence for either of those possibilities. And remember, genetic evidence, genomic evidence is very easy to come by. If either of those were true, it would be very easy to find the evidence. So I wrote, I was asked by Science Magazine, which is run by the AAAS, to write a review of this book. And so I started, and I had a bunch of material, and I decided to invite some friends in with me. So I had Josh Swamidas, who I won't have time to talk about today, but also Richard Lenski. And I chose Richard Lenski because a whole entire chapter of Darwin Devolves is based on his work, Richard Lenski's work. So we together wrote this review. And I decided, since I had all of this material to use, that I wouldn't, and I think we were limited to 750 words or something, and we had pages and pages of material of all of our critiques of this book. I mean, every chapter of this book is just littered with problems. So what I did was I spun off little bits and pieces of this into other reviews. So I published this in Science Magazine, and then I published another version of it in Skeptic Magazine, and they gave me the cover. That was kind of cool. And then AIPT, which is this is run by a friend of mine. It's basically a geek website for science geeks and comics and other kinds of geeks. And so I picked different criticisms for each of these reviews, and then I published them all within a couple of weeks of each other, patting myself on the back for learning from them. But let me tell you, they didn't like that. I want to first cover a little bit about what's wrong with the book. First of all, it repeats the claims about irreducible complexity, which we've already debunked. But then he also completely misunderstands the long-term E. coli evolution experiment. So this is an experiment run by Richard Lenski, my co-author on the first review, that's been running for years and years and years. 75,000 generations of these bacteria have been growing, and they've been watching how they evolve over time. And he really took umbrage with the misrepresentation of his work. And so he wrote several reviews of his own, and they're in on his website, and this is the name of the website. And so you can go and read those. He also completely misreads Darwin's finches and the lemurs of Madagascar. He almost catches this mistake. So let me just tell you a little bit about those. So one thing he did was he talked about how Darwin's finches, Darwin discovered that there were many species of finches on the Galapagos Islands, which is an archipelago off the coast of Ecuador and Peru. And there's many species of finches, but they all seem to be pretty related, but just adapted to the food source that they have on each one of these islands. One eats seeds, one eats leaves, one eats whatever. So you have these different finches, and they look like the ancestral population on the, he didn't say that at the time, but it looked like this population on the mainland. So maybe they got stranded, populations got stranded on the islands and evolved in this new way. It's a classic example of evolution. But B is very upset that these finches haven't evolved into anything else. All they did was change their beak a little bit. All they did was their wings got a little tighter. That, why didn't they become hawks? Why didn't they evolve into flightless birds? Why? There was all kinds of different directions that the finches could have done, but all they did was just double down on the food source that they had available. So the problem with this is that there were already hawks on the islands, for example, and other birds of prey. The finches didn't arrive to a vacant space, right? They were already, so all they could do was what they already could do. All of the others, as we call ecological niches, were already filled with other birds. So the finches had no way to adapt into those roles. Also, they only had about 2 million years to do it, which is not a lot of time in evolutionary timescales. And he offers the lemurs of Madagascar as a counterexample about how they evolved into all these different things in a relatively short amount of time. By the way, short amount of time is something like 35 million years. So that's a lot more than 2, for example. And secondly, there were no mice on Madagascar. So we have the mouse lemur. There were no sloths. So we have the sloth lemur. We have a lemur that looks almost like a gorilla because there were no other primates there. So this is actually, he's so close to getting the point that when the ancestors of the lemurs ended up stranded on Madagascar, those niches weren't filled by other animals, and so they could evolve into those things. It's actually a wonderful counterexample for what evolution can do when it has the space to do that. And like I said, it was also 35 million years versus 2 million years, things like that. So he almost gets the point. He's so close to getting it. Anyway. Some other things that are going on. He completely ignores the ways that we know complexity and innovation come about. So for example, exaptation, he doesn't even mention it. And that's when one structure gets evolved into something else. So feathers that evolved for thermal regulation being adapted for flight. He doesn't mention horizontal gene transfer. This is the exchange of genetic material between 2 unrelated organisms. These were major events in evolutionary history. Doesn't even mention it once. The word recombination only appears once. Recombination is when you get new combinations of genetic material in this creative way, which we see, happens all the time. And also gene duplication and divergence, which is, again, a major theme of evolutionary theory, where you have a gene that gets duplicated into 2 copies. Well, in real life, when this happens, it's wonderful because one copy can retain the original role of that gene, and the other one is free to be tinkered around with without harming the organisms until creative stuff happens. He calls it insufficient. That's all he says. Well, gene duplication, that's insufficient. Says who? We have excellent examples of gene duplication, including the blood clotting cascade, by the way. And because he called this insufficient, I was pretty pissed off, because there was a paper that came out not too long before his book was written, and that basically showed that real-time evolution of new genes happens fairly quickly, 2,000 generations or less, under the right conditions. And I want to just show you how this works. So this is out of Dan Anderson, who's a major molecular evolutionary theorist. In his laboratory, they took strains of yeast, and there's an ancestral bifunctional gene. So this gene can kind of do 2 different chemical reactions. I should say the enzyme can do two different chemical reactions. With no manipulation whatsoever, these genes will spontaneously duplicate. That gene duplication just happens. Over time, under the right selective conditions, they will evolve into 2 different functions based on the needs of the organism. So within a few thousand generations, they were able to observe many different ways, all different mutations, different pathways that these genes could take to evolve into 2 separate genes that do totally different things for the cell. One is to create histidine, the amino acid histidine, and one is to create the amino acid tryptophan. So from an ancestral bifunctional gene, we get two divergent genes that now can do the two activities separately. And this is with no manipulation. This is just allowing nature to take its course, providing the selective pressure. So that was the one manipulation, is that we gave an advantage to doing this. So what this tells us is that once the conditions are right, organisms will spontaneously play around with their genes in enough weird combinations until good things happen, and then they get selected for. That's the genius of natural selection, is that success breeds success. Okay, so we had all these. This is a paper I made a big deal about my review, because it's to not even mention this work as the major criticism. I mean, it does exactly what Behe says evolution can't do. We've seen it in the lab. So I got pretty pissed off, and I made a big deal about that. But I poked the squid with my reviews, and oh man, the Evolution News had a great time with us.
How unfortunate that you got more free publicity.
Yeah. Yeah, I mean, listen, I was having a blast, I have to admit. I stayed up till 2 or 3 in the morning, lots of nights working on this stuff. I had a good time. I mean, I have a day job, so I had to do it in the evening, but I had a lot of fun doing this. And man, but they came after me over and over and over and over. Really mad. And again, upping my profile in the community, which is great, and I appreciate that. However, there was one, and I do want to say is, we published our review in Science. We were limited to 750 words, but another group of scientists, a pair of scientists, decided to go into Darwin Devolves much more thoroughly than I did, with much more erudition and expertise, because they are molecular evolutionary theorists, and they wrote a review called Evolution Unscathed, which was in the major, this is the journal, the primary journal of the Society for Evolutionary Biologists in the United States. So it's like the major professional organization for evolutionary scientists. And they wrote this review, which was, I don't know, like 5,000 words. They weren't limited at all, because this is an academic journal. It was peer reviewed, heavily sourced. It was the opposite of what we wrote. Ours was really brief, and we had like maybe 10 or 15 sources, but they really went into detail. Gregory Lang and Amber Rice are colleagues of Michael Behe's at the University of Lehigh, at Lehigh University. Yeah, so two of his colleagues, which were both junior professors at the time, it was pretty impressive that they did this, but it was really just a breathtaking takedown of the book.
So of course, Behe admitted he was wrong, right?
We'll get there. So just to give you a couple of quotes from this review, I mean, it's just, I was trying to be a little bit more charitable, but his colleagues, I love this last one. Without a hint of irony, Darwin Devolves cautions us that the academic ideas of nutty professors don't always stay confined to ivory towers. They sometimes seep out into the wider world with devastating results. And all jokes aside, they really did an excellent job, very thorough. If you are in any way interested in evolutionary science, it's an excellent review, and it shows all kinds of ways that evolution has done exactly what Behe says that it can't. Now, of course, he didn't take this laying down. He wrote a 3-part response to them, but he did do it himself. He didn't rely on the others at the Discovery Institute, and he was charitable in his responses to them as well. They're his colleagues, and I think he's generally a nice guy. But his summary of what he said was, I mean, he didn't offer any, and I read these very, very carefully for evidence for his position, rather than just arguing with what they were doing. And there's nothing even close to like evidence, data. There's a lot of rhetoric, and it doesn't mean they're all good writers. Michael Behe is actually a very clear writer. You can read his book quite easily, and that's part of why he's so convincing, is that if you don't know all the data and the evidence behind these positions, he's pretty convincing. So a quick summary.
What troubles me so much about some of these books is that they know who their audience is, and they write in a way that's more accessible than the more scientific material that's out there, which is not necessarily accessible to the people who need the information.
I think that's right. I think they have, through practice, really learned to excel in writing to the public, particularly the non-science public. And that, I mean, that's to their credit. I got to give credit where due. They knew they are not going to convince scientists, so they don't write for scientists. I mean, that's the thing. Like Behe's published like 2 peer-reviewed articles in the last 25 years. You know, he's not real active as a scientist, but he's certainly active as an author. Anyway, just let's summarize real quick about all the different ways that it's wrong. First of all, the most basic claim is both obvious and unsurprising. We've known for a long time that you can't actually get what looks like a harmful mutation that actually helps the organism. We'll give you one example of that in a minute. But another, it's also way overstated because the examples he uses, he doesn't even just take the win on those examples, he exaggerates them, and I'll give you an example of that. And then any counter examples are just simply dismissed out of hand, and there's lots of those out there. One thing I also want to talk about is if you look at the genetic diversity in any species, and this works with humans, we actually have very low genetic diversity as a species. We're very bottlenecky, inbred kind of species. But if you look at genetic diversity across species, the vast majority of variability, like the gene pool that's out there, are not in degradative mutations. They're actually in just slightly different tweaks to a functional version of these proteins, which tells you right away that innovative mutations are not hard to come by. They're not as common. Of course, it's easier to break a protein, through mutation than it is to create a new one. Of course, everybody knows that, but they don't persist. Harmful things disappear, helpful things persist. And that was the point I was just making. So yeah, degradative mutations are common, but they're not important, and they get eliminated from the population, or they just become neutral. He also uses the word natural selection and evolution. He uses those terms interchangeably, which they're very different things. Natural selection is a mechanism that acts generation to generation. And of course, evolution is just change over time. And he calls both of them Darwinism. Anyway, he totally ignores things like genetic drift, which is actually we know is more powerful than natural selection. Neutral theory, the vast majority of genetic differences between us is neutral. Recombination, which is the shuffling of material that we all have into new combinations, which doesn't require any mutation, by the way. And you can get a change in how a gene is expressed by just moving where it is in the genome. And the gene itself is completely unaltered, completely ignores that. And in fact, a paper I just published was on that. Like the location of a gene in its local neighborhood in the genome is super important. Exaptation, I already mentioned. Sexual selection, which he doesn't talk about at all. All of these are other mechanisms of evolution. I mean, he's always like, natural selection can't explain it all. I'm like, yeah, we know that. We've known that for a very long time. That's why we have all of these other mechanisms that you don't talk about. And then there are mechanisms that have generated novelty. So for example, there's this, it's a gated ion channel in this PCP digesting sphingomonids. And this is, by the way, the preservative PCP, not the drug, illicit drug. And this was cobbled together with non-functional DNA just randomly coming together to form a gated channel in the membrane of these cells. It's really quite amazing. He doesn't answer it, doesn't talk about it, he pretends it doesn't exist. It's a great example of evolution doing what he can. He ignores, as like I said, niche occupation. I talked about that one. He forgets that genes have multiple proteins, or I'm sorry, multiple binding partners, and they can do different things. All of these are all mechanisms that we know create diversity and divergence. He also exploits our ignorance of facts that we can't possibly know. So how, point mutation by point mutation, you get from this version to this version. Well, proteins don't fossilize very well. Genes don't fossilize very well. We can only look so far back in the past using molecules. And before that, prior to that, we don't know anything about the dinosaur genome. We just don't know it. And he exploits that ignorance to say that we don't have the explanation.
So he actually uses the argument for ignorance fallacy without knowing he's doing it.
Right, exactly. Exactly.
So is that a fallacy from ignorance?
Yeah, he's ignorantly using the fallacy, the ignorance fallacy. But what the most interesting about me is that I think about this is that evolutionary theory is held to this impossible standard, but his own idea, he doesn't even try to support with evidence. He just says, well, if evolution can't explain it, it must have been the intelligent designer. He has it as this sort of vaulted default position that when everything else gets criticized, that position remains, right? And there's a word for that, unfalsifiable, which means it's not scientific. It's just a claim that we can't really quarrel with. Because I can't prove that it wasn't the hand of God that went in and switched a mutation. Like, I can't prove that. But that's what you're resting on when you're looking at intelligent design. Okay, so one thing I want to talk about is specific. How much time do I have? I don't want to.
Oh, you're good.
Okay.
We have, yeah,
Okay.
as much time as you need.
So there's this one, I think, really good example that really exemplifies how committed they are to misreading the evidence. So there was one of these are all the articles that they freaked out after we had the science review came out. There was one about polar bears. And he says, I am really surprised they didn't even discuss my example about polar bears and how clearly that shows how harmful mutations have led to adaptation of the polar bears. And it's true. When I read that, I just breezed right past it. I didn't look very deeply into it. It all kind of sounded right. And the lesson here is don't give them an inch, because this was his opening example. I gave it to him, as a pass, and I didn't look into it, and I really regretted it. So let's talk about this. Recently, we have sequenced the full genome of not just polar bears, but also brown bears, other bears, including panda bears. We have the full genomes of all the bears now. And so we know quite a bit about how the recent evolution of polar bears from their ancestors, which are common ancestors with brown bears, that were probably pretty similar to brown bears. I don't want to say that brown bears evolved into polar bears, because that's not right. Present day brown bears have also been evolving, but they haven't been changing much because they're living pretty much the same way that they were then. Whereas polar bears have changed because they migrated north, etc. Actually, they found themselves north. Okay. He talks about how all of the changes that you see in their genome from polar bears to brown bears are degradative, destroying mutations that have now made them polar bears. And for the example being, if you look at how they got white hair instead of brown hair, it's that the genes for pigment loading have been broken and they don't function anymore. And so you basically have an albino brown bear. So first of all, polar bears are not just albino brown bears, but the point about the hair, he's right. There's a gene called the List gene that gets broken by mutation, and it did turn their hair right. And that's why I just kind of breezed through the example. I was like, yeah, okay, that's a good example, whatever. Well, he grossly exaggerated everything in this. And when I went back and took a closer look with my friend Art Hunt, we started to look a little carefully at this. First of all, weirdly, his math is wrong. So if you look at the data that he presented, and of course we went to this is the original paper, by the way, that he's discussing, that came out in 2014. So we went and got the original data. So he claims that 65 to 83% of the genes that were that the genes that have evolved had at least one damaging mutation. So that's where he's getting his it's mostly harmful mutations that harm this. So let's look at this claim for a second. First of all, it's exaggerated. It could be as low as 40% by the numbers in this paper. So I don't know where he gets 65 to 83. So he exaggerates. The other thing is that he cherry picks which algorithms he uses to determine which ones are harmful mutations and which ones are not. I'm going to talk about that in a second. And thirdly, this is the most grossly dishonest thing so far, is that he counts one probably damaging mutation anywhere in the protein, and he counts that as a damaged protein. Remember, there could be 15, 20 other mutations, any one of which could be helpful. All of them could be helpful potentially. But if it has one possibly damaging one or probably damaging one, then he counts the whole thing as broken. And it's like, well, if we took that trick, then every single one of the gene has helpful mutations, because they all have tons of mutations in them, right? Polar bears and brown bears are separated by about 10 to 15 million years of evolution. So there's a lot of genetic change. It's incredible cherry picking. So imagine a protein has 20 changes. One of them is found to be probably damaging, and he counts the whole thing as damaging. What if the other 19 are helpful?
This is like Ray Comfort's thing, where have you ever told a lie? Then you're a liar. He doesn't say, have you ever told the truth also? Then you're a truth teller.
right. Then you're a truth teller. Exactly. Very, very good. I like that. Okay. So let's go and look at what he calls is the most strongly selected gene. So this is the gene that has undergone the most positive selection. And what we say in evolutionary terms is this is the gene that's done the most in the evolution of this animal. ApoB. First of all, it's not the most, it's the second most. He did eventually admit that mistake. That's the only mistake he admitted. But anyway, ApoB is responsible for clearing cholesterol from your blood following a high-fat meal. So if you eat a meal with a lot of fat in it, you probably know that the lipids don't last in your blood too long, they get cleared. And one of the proteins that's involved in pulling that fat out of your bloodstream is called ApoB, apolipoprotein B. That's its job. So it clears cholesterol out of your blood. Well, we also know that the polar bear diet is much higher in cholesterol than brown bear. Brown bears, they're mostly vegetarian, but they do eat fish. But these polar bears eat seal fat, basically blubber, as a major part. So their diet's way higher in cholesterol, and they do not develop atherosclerosis. They don't get heart disease with this high-fat diet. And ApoB is the gene that's most evolved. His claim is that ApoB is damaged. So this is the gene that protects you from cholesterol in your blood. And they have a high-fat diet. And he's saying ApoB is damaged, and that's what made them able to do this. So I said, well, that doesn't sound right to me. It sounds like they probably should have a better ApoB gene. So let's go in and look. So we went into the paper, Art Hunt and I, and sure enough, we found that not all, but most of the mutations cluster in the N-terminal region, which is a specific part of the protein involved in pulling cholesterol out of the blood. So the most functional part for the cholesterol bit of this protein is where most of the mutations are. So if they were damaging mutations, you would expect them to be evenly spread throughout, but they're clustered in right where the protein is doing its job. So that's when we realize something's going on here. So, and more evidence. So he doesn't discuss this, but when humans, mice, and other creatures suffer damaging mutations here in this N-terminal region, they're more prone to heart disease, not less. So there are humans out there that have mutations in this, and they're more likely to develop heart disease. If any of you here who have familial heart disease that runs in your family, you could have sort of a bad version of ApoB, and that could be why. But apparently the polar bears have a better one. I don't know. So he claims that the authors determined that the mutations were very likely to be damaging, that is, likely to degrade or destroy the function of the protein. That is Behe's quote, not from the article. If you read the article, what the authors actually said was adaptive changes in ApoB, which enable the species to cope with a high fatty acid intake by contributing to the effective clearance of cholesterol from the blood. So I don't know how he got that sentence to say that the mutations were likely damaging, but he misrepresented what the authors said. And I wrote to the authors and they were like, I don't know where he got that from our paper. It's very clear that ApoB is functional, is highly functional in polar bears, and that's what saves them from heart disease with his high-fat diet.
Is it something like he's basically just deciding ahead of time that if it's a mutation, it's damaging, and he's just calling it that?
I think so, and you're going to see my evidence for that. So Art and I wrote this up, and I wanted to do it quickly. This is like, we did this in the evening, took me about 4 or 5 hours. Art and I kind of go through the paper, and I write this little blog post and put it on this is my blog. The Human Evolution blog is mine, and here's another example. This, by the way, this is after all the reviews have come out. Here's another example. He gets polar bear evolution wrong too. It was his opening example. We should have looked more carefully, but we didn't. Here it is. And he got so mad. So Michael B, he lost his cool, and he called me incompetent. And he didn't see my review. I don't know if he did, but Jerry Coyne, who maybe you may know, he's one of probably the most famous evolutionary biologist in America. He's like the Richard Dawkins of America, and in many ways, actually. And he blogged about our blog post. He noticed our blog post. Actually, he and I might even about it. And he posted this saying, wow, he screwed up polar bears too. And so he calls this a mind-bogglingly shoddy review in Science. And he calls him and another guy. I'm him and another guy is my friend Art Hunt. Whatever, he goes after us. But he didn't even defend the claim. He just rambled on about what a bad job we did. And then he finally offered 2 sentences of actual defense of his position. Here are those 2 sentences. He said, below is the relevant information from Liu et al. That's the paper, the polar bear, sequencing the polar bear genome, that paper, from table S7, which means it's a supplementary figure. Those who can understand the table will see that it supports every actual undistorted claim I made about the polar bear. And then he offers this chart. Now, here's a problem. I actually had read the paper the night before. I had spent a lot of time reading the paper because I want to make sure, what I'm saying is right. And I didn't recognize this chart. He posted it and I said, this does not look familiar to me. I haven't seen a chart like this. Some of the information looks familiar, but I haven't seen a chart like this. So I went to table S7. This is not table S7. So here's what he posted. Here is the real table S7. So you'll notice it's much, 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 much larger, right? So he's omitted information from this table in order to make his point. And remember, what's his point? His point is that the majority of mutations in the polar bear are damaging. And
So for people who are going to like first hear this just on audio, could you just describe the major differences?
Okay, I'm going to get there. I'm going to get there. So on the left, he has a chart that says every single mutation that he lists is called probably damaging. Now, what this is that this is a predictive algorithm that looks at the structure of the protein, and based on what we know about how proteins work, it predicts a mutation as being either benign, possibly damaging, or probably damaging. One thing I want to point out is those are the only three options for the algorithm. We are not so good at protein prediction that we can say, oh, that's a helpful mutation. That we can only determine that experimentally. All we can say is possibly or probably damaged or not damaged, meaning benign might actually be helpful for all we know. We just don't know. So the only output is harmful or not harmful. This chart shows all the mutations as harmful, probably damaging, or possibly damaging. But he didn't present the whole chart. He presented the data that supports his position. The real chart, you'll notice, is about twice as large as what he presented. And it doesn't just have more rows, it has more columns. So I'm going to now look at the actual chart. And I'm going to show you what he left in and what he didn't. It's too big because the writing is too small. So I'm going to look at the top half only, but just it's the same pattern throughout the whole chart. And I did it through the whole chart, just to be clear. So here's the top half of the chart. This is the actual chart. Now I want to show you, there's two columns here that say whether it's benign or whether it's damaging, the mutations. So all these mutations are mutations that the polar bears have compared to brown bears. And these two different algorithms, there's two different ways you can do this. One's based on human clinical data and one is based on protein structure. It's a technical difference. But there's two different ways that you can predict if the mutations are benign or damaging. And you'll notice that the algorithms don't always agree. Some say it's benign, some say it's damaging, some they agree, some they don't. Well, which algorithm do you think B he chose to show you? Oops.
Oh, I bet it was the one that showed more of them being damaging.
You're right.
You're psychic, Kara.
You're right.
That's what they keep telling me.
You're right. So I circled in red the two columns that he left off. And you'll notice that the word benign appears much more often in this column than in the column that he showed, because he wants to give you the impression that all the polar bears mutations are damaging. So what he did was he just simply removed these parts of the chart that will show you that actually most of the changes are benign. And remember that benign could also be helpful for all we know. We'd have to go and do experiments to determine that. But most of the mutations, something like 60% of them, are benign according to this algorithm. But it's more like 40% are benign by the one he wants to show you.
If you look up the phrase cherry picking in the dictionary, there should be his name right there.
Well, I'm not done though.
Picture.
Rob, I'm not done. He didn't just remove columns, he removed rows too. Which rows do you think he removed?
Yeah, duh. Anything that's double benign.
Every instance of the word benign, he removed from the chart. He removed every instance of the word benign. So the parts that I've circled in red here, and you'll notice it's most of the chart now, is the parts that he removed to come to that version of the chart that he showed you. And I'll back up to show you that chart. See that? They all say possible or probable damaging. And if you go through all the columns, he's left in all the ones that show you or that predict that his idea about polar bear evolution is correct, which is that it's basically polar bears are damaged versions of brown bears.
If he was a medical doctor, he'd be open to a medical malpractice suit for this.
It's incredibly dishonest. There's no way to see this any other way than incredibly dishonest. Because he's removed all of the data, but these is predictive algorithms. It's not the same thing as data, but still he's removed everything from the chart that argues against his position, and he kept in the minority of points that actually argue for his position. So I didn't want to fight with this guy, so I just sort of put it in as an update. I updated the blog post that I already had with the new information, and then I put it in there because at this point it's getting a little like, okay. But I did tweet out this chart with the red circles and everything out. And, oh man, what do you think the Discovery Institute did with this? Oh,
they admitted they were wrong?
Nope, they didn't. That would be benign if they did that. They didn't. No, they did not do that. They had all of this. They did. I think it was like a 5-part series on the polar bears and retracting versus not retracting errors and a fake scandal about a chart. They just were kind of freaking out. At this point, and then I've actually heard from someone that behind the scenes, people at the Discovery Institute were really pissed at Michael Behe for putting out this chart because it really makes them look egg on their face. I mean, it's the stickiest egg you can have in your face to doctor a chart of data, throw it up there, and like we're not going to notice. How are we not going to notice that? Anyway, and they also released one article with the best title. It is "Remind Me Again Why We Pick Followers." I'm sure everybody's thinking that same thing. Anyway, so that was the fun that we had. This is all like February to March kind of. We were having a little too much fun with this, but we were done with the polar bears, and Darwin Devolves seems to have been mostly a flop. Nobody's really talking too much about it, and I'd like to think it was partly because a lot of us got together, took time out of our lives at night in most cases to debunk it. And I saved my last criticism, or I saved what I think is the best criticism of this book for last, and that is the word devolves makes no sense biologically. There's no such thing as devolution. He's offering it as the opposite of evolution. Like evolution is things get better and more complex. That is not at all what evolution is. Evolution is just change over time. It's neutral. Actually, streamlining towards simplicity and efficiency is a very common evolutionary route. That is not devolution, whatever that means. The word devolution will never appear in any science textbook. They literally just made this concept up of devolution. And that's my ultimate criticism, is the whole book has this really dishonest premise. And you can't really understand evolutionary theory if you think increasing complexity is good and decreasing complexity is bad and devolution is the loss of. No, simplicity and streamlining, that we see a lot of that in the genome. We see a lot of genes being broken, tossed aside when they're no longer functional, and that's still progress. Humans have 15,000 pseudogenes. These are genes that were formerly functional at some time in our ancestral past, and they no longer are. They're no longer serving our needs. A lot of them are just duplicated versions of other things, but once they became duplicated, they were no longer necessary. There's just a lot of aimlessness in evolution. It doesn't have a target. It doesn't lead towards more complexity or more innovation. A lot of times, actually, the most complex organisms fail because of how much energy and resources are needed to maintain that complexity. In fact, humans are often called the most unlikely of species because it really took a lot to get us here, a lot of unlikely events. And so the idea that we should be grumpy about devolution, it really does not make any sense at all. And to me, it really speaks at the heart of the kind of bias that's working in Michael Behe's brain, because he wants to see this steady march towards progress and perfection that leads to human beings. But that doesn't, we're just another life form on the planet in terms of the biological history. We're not any more evolved. And he says that too. Humans are more evolved than other primates. What do you mean? That doesn't make any sense at all. We're all alive. Any living species that we have common ancestry with, they have the same ancestry we do. They've been here evolving the whole time. We have some important cognitive adaptations that some other creatures don't have, but we are no more evolved than the E. coli that live on our body and outnumber us, by the way. There are more E. coli cells in your gut than there are human cells in the whole rest of your body, right? So they're very simple compared to us, but they outnumber us even on our own body. It's hard to say that they're less evolved. If they've evolved a very successful way to thrive, and that is through simplicity and being small. So anyway, devolution is not a thing, and if you hear anybody using it, it's wrong. Call it out if you can. That's all I have for you today. I would love to take some questions, though. I think this will be fun.
Well, we have a ton of questions, so I'm glad that you are ready to take some.
Yeah, let's go.
We'll get through. Yeah, okay, we'll do as many as we can. So I guess for now, we'll just switch off asking some of them. So let's see here. Some of these have to do with kind of your thoughts on different books and concepts. Others of them are a little bit more about biology specifically. So hopefully you understand them. There are some that I'm not sure about. So the first one is actually, someone was wondering what you think about another book called Finding Darwin's God by Ken Miller. Do you have any thoughts on that book, or are you familiar with that one?
Yes, I am. I don't think I've read the whole thing. I read passages of it because I reviewed Ken Miller's more recent book called The Human Instinct. I think that's his most recent book. It came out a couple of years ago. Kenneth Miller wrote a book called The Human Instinct. Finding Darwin's God. So Kenneth Miller is an interesting character because he is a very staunch defender of evolutionary science, and he was a plaintiff in a witness for the plaintiff in the Dover case. So he's a scientist at Brown, I believe, in Providence, and but he's also a Catholic, and he's a devout Catholic, and he writes about evolution for religious audiences so that they can see that it's not scary, it doesn't threaten their beliefs if they understand it right, and that perhaps evolution and natural selection could be part of a grand scheme that God might have had. So that's what the passages I read, I can't actually remember what they said, but it allows for science to have unfolded exactly as it has. Ken Miller is one of Michael Behe's staunchest critics, and he's a hero of defending evolutionary science in public. But he's a Catholic, but one thing that's funny is I saw him on stage once, video of him on stage with Richard Dawkins, and Richard Dawkins was kind of critiquing some of his views about the resurrection and all this. And Kenneth Miller stopped him and he said, "Listen, Richard, I believe in the resurrection, but that doesn't mean I think it's true."
Just wow.
But like, I kind of get it too. It's like, listen, we just have like, I kind of believe in karma, and I'm like, well, that's because the energy you put out and it comes back to you, blah blah blah. Like, do I actually think it's true? Probably not, but I believe in it because I think if you put out, what you put out in the world does come back to you in terms of reputation, how people treat you, and all that. There's something to that. But I actually kind of respect that position that he has. He's like, look, I'm not going to defend the veracity of the resurrection. I'm going to say it has meaning for me and leave it at that, and then leave it at home. Whereas in the science classroom, we're going to teach science. So I think I would recommend any book by Kenneth Miller.
Okay. I want to point out that we're not taking hands up yet. I don't know why people are doing that. We're reading questions that we collected from the chat, so you can lower your hands for now. What are your thoughts on the current SCOTUS perhaps reversing the decisions regarding creationism and teaching in schools?
I think it's a real concern. I think it's a real possibility because they have shown, no regard for precedent on all of these things. And the last Supreme Court precedent was from 1986, and it was really geared towards young earth creationism that didn't hide itself in any other way. It was really offered as biblical, and so I don't think the current Supreme Court would ever reverse that, although you never really know, right? But I do think that they would be very amenable to arguments that intelligent design could be offered as an alternative in a science classroom. I mean, mandates maybe not, but I could definitely see the Dover case, for example, being appealed eventually, in the hopes that there are enough Trumpian federal judges now that, I think it's a dangerous time. What's odd though is that it's really at odds with the public, because acceptance of evolution, while it was kind of stubborn for a while, it's really taken off in the last 10 years, five years, I guess. The NCSC, and Rob, you might know this better than I do, but I think evolution acceptance has finally started to steadily improve in the last few years, right?
Yeah, that's the kind of things I've seen in polls. I mean, it's not extremely high, but it is on the upswing.
It's on the upswing.
Yeah.
And religiosity seems to be going down a little bit too.
Yeah, that's absolutely true. Although
Yeah.
people come out of mainstream religions and they just believe other bullshit.
Right. So I am a little leery of what the Supreme Court could do. Yeah.
Okay, well, I've got one that just came in the chat a minute ago, but is similar to a few others that I've seen throughout the talk. There are several people that have commented on, after hearing your discussion tonight, they're really discouraged at the education that they received in school and that they didn't learn all of this to begin with. And they're wondering if you could suggest some resources or even like YouTube videos or things for lay people without a science background where they could kind of catch up on biology and evolution if they didn't get this in school.
Okay. Well, I think, let's see, what would I consider? With YouTube and those, I'm not the best source of what are good YouTube pages. What I can tell you in terms of books that I would read, I mean, there's the classics. First of all, The Greatest Show on Earth, I would recommend that book as well. I would recommend The Ancestor's Tale by Richard Dawkins. And I mean, The Selfish Gene is 1976, but still a great read, and it's been updated. And The Selfish Gene really changed a lot of people's views on evolution and on working really at the level of the gene. I personally am also a fan of David Sloan Wilson's writing, but he's something of a pariah in the evolutionary community because he supports more of a group level selection, which isn't very well accepted yet. Multi-level selection, as he calls it, but he writes very clearly about evolution. So I would recommend David Sloan Wilson. I would read Richard Dawkins, Sean Carroll, and that's Sean B. Carroll. There's Sean Carroll, the physicist, who also is a great science writer too, but it's physics. And then there's Sean B. Carroll, who was one of the early founders of a field called Evo-Devo, which is evolutionary developmental biology, which is the idea that a lot of these mutations that tweaks who we are really act during development. So the nostrils turned into blowholes in dolphins and whales through just the subtlest changes. Really, genes themselves weren't even changed, just when they got expressed during development is what changed, and that moved the location of the nostrils. Things like that. So Sean B. Carroll, Richard Dawkins, Kenneth Miller I recommend too, and things that he's written. Off the top of my head, what else would I recommend?
For people who are more visual than book readers, I would definitely suggest RfR. He's got a long series on evolution. And he actually, he's been interested in this a very long time. And he actually went back to school, and he recently just got a degree in anthropology. So yeah, he knows this stuff.
Okay, great. Carl Zimmer's another one that writes great stuff. I'm just looking at my bookshelf here. And Donald Prothero, if you like paleontology, he's written a bunch of books, like the 25 famous fossils on this, 25 this, that, and the other. And they're all pretty.
One of the books I read from Dawkins a long time ago was The Blind Watchmaker, and that was really instructive because they always throw out there about, like you mentioned, the complexity of the eye. It can't have happened by accident.
Yeah, Blind Watchmaker. I think I've read 5 of Dawkins' books: Ancestor's Tale, Greatest Show on Earth. Oh, and also The Magic of Reality. That one is not so much about biology. It's actually all of it. But The Ancestor's Tale too is a good one. Anyway.
Okay, we will make all of those available to people in our notes here. I'll pull links to some of those so we can refer people. That is super helpful because I know I need to brush up too. And I agree. We actually, that book cover that you showed a minute ago, of Pandas and People, they used that in my middle school. We read from that textbook. So
oh my.
Yes, we had that, and that was in the 90s. So yes. Okay.
Wow. So we had a bunch of questions on junk DNA. One person said, I've heard of junk DNA. What is it? Is it really junk? Another said, if some junk DNA is actually functional, could that indicate that other junk DNA has functions that we don't yet understand?
That's a great question because it's an area of research that I'm in. I do use the term junk, even mostly to annoy people that don't like it. That's why I do it. We have huge stretches of the genome that are either not functional or not doing anything good. And so we call them junk because there are a lot of times it's remnants either of former genes that have gotten broken, but actually most of it is what we call parasitic DNA. So there's DNA that's really good at just simply copying itself and making more copies, and it's hard to get rid of that. But occasionally a piece of this DNA can get retooled for a function. A piece of non-functional DNA sort of comes back to life. Even pseudogenes are sometimes resurrected. And in fact, I published a paper last year about a region of the genome that got retooled to form a microRNA gene, a series of microRNA genes. This is very rare when it happens. It's very exciting. It's very cool. I still maintain that all of this is junk, because junk can sometimes be reused as well. It doesn't, just because it can be reused doesn't mean it's not junk, right? So if you go to a junkyard, it's junk, but you might get, a spark plug out of one of those cars and it works fine and you can plug it into something else. I don't know, do cars still have smart plugs? I don't know. But you know what I mean? So you have your junk drawer in your kitchen, right? Like if everything in there disappeared, you probably wouldn't notice right away. But every once in a while, you're like, oh, that's where the staple remover is. Why did I even have that? So, I mean, I think, and when I say that large regions of the genome, it's more than half of the genome. Well, actually, I would put this number at 75%. I'm going to say something bold, but I think it's true. 75% of the genome is not maintained by selection, meaning 75% of the genome can be lost or mutated with no deleterious effects on us. 75%. Because it doesn't have what we call the marks of selection, the marks of being maintained by natural selection, meaning that it's free to mutate and no difference gets made. That means only 25% of it's maintained by selection. So you notice I'm not using the word functional versus non-functional, because that gets a little dicey, because things can change over time, even time of day, different areas of the genome can become functional. But 25% of the genome has been maintained by selection, so it's important. And the sequences there are important. 75% is unimportant junk, but that doesn't mean that it's not expressed. Sometimes you do get what's called spurious transcription, not sometimes, a lot. You get spurious transcription. So the DNA is being made into RNA, and some of that RNA might even become protein, but it's not doing anything, or at least it's not doing anything helpful. But, and this is the key part, is that is the raw material that evolution could work with in the future, right? It is spitting out molecules that are binding to other things, and it'll be sort of aimless, promiscuous kind of binding. But once you get something functional, then natural selection can kick in and develop it further and refine it. And over the generations, it can become something important and interesting. And in fact, there's a study came out, I think that's almost 2 years ago, in Drosophila, that watched new genes being born, in theory, but new genes being born, and how quickly they became important to the organism to the point of being essential. And so evolution can work relatively quickly at the molecular scale, but it is breathing life into previously non-living areas of the genome. So I do maintain, and I will argue with anyone on this, 75% of our genome is junk. That doesn't mean it doesn't have potential. It doesn't mean it might come to life. And there might be little things in there that we find function for, but that doesn't mean that the 75% number is wrong. It just, it means we're refining our knowledge of it.
So Nathan, when we hear a scientist saying something like, we share X% of our genome with whatever, a banana or chimpanzees, does that include the junk DNA when they're doing that calculation? Or is it throwing that out and then saying usually the rest of it?
Yeah, it's usually throwing that out. It depends on what comparisons are being made. So if you are talking about a human and chimpanzee, generally we don't throw anything out, because our genomes line up so well that we can throw out a number like 98.5%, which isn't quite right, actually, because that's ignoring deletions and insertions. But the human and chimpanzee genomes line up pretty well, whereas the humans and bananas do not. So it would be very hard to come up with any number. So what we do instead is we look at the genes. How many of the genes maintain enough sequence similarity to be detected as in common? And that number with bananas, for example, is about 40%. Which seems really high because you have bananas and you have humans, but you got to remember that most of the complexity that makes us is inside the cell. And the cells work very, very similar from organism to organism. And so a whole lot of genes and proteins and molecules are shared with even the most distantly related things, because the most essential functions of life are at that tiny scale, and they're very, very well conserved. But those numbers, so everyone says we're this similar and this similar. Every time they throw it out, it's a slightly different comparison, because when they don't line up very well, it's hard to even come up with that figure without it being somewhat distorted one way or the other. So generally, we're talking about functional genes.
Thanks.
So it's like, comparing chimps to bananas, apples to oranges.
Yeah.
See what I did there?
I do.
Okay, I'm here all night, y'all. Okay. we've got some others. This one's a little bit more of a technical question, so feel free to address it in a technical sense or a broader sense. You mentioned something earlier about blood clotting, and someone was asking a follow-up question. They were asking, with the blood clotting pathway, would the common pathway evolve first, or the intrinsic or extrinsic pathway? And how do you counter irreducible complexity for the clotting cascade? And I hope you understand that question better.
I do. I'm not an expert on this by any means, but I'll give you my understanding of it. So the clotting cascade, when you have a wound, so a vessel gets broken, a couple of signals get released when a vessel gets broken. Some of it just comes from the underlying tissue itself, because your blood, the inside of the vessels of the blood just sees blood, right? And if it suddenly sees proteins that are normally in tissue, it means that the vessel's been broken. So we have some tissue damage here going on. And that initiates a cascade that we call the clotting cascade. And the clotting cascade is made of primarily of what are called proteases. And a protease is a protein that chops other proteins. And so you end up with, you have this large protein in its inactive form is large, and then you cut off part of it, then it becomes active. So you have to actually remove the negative switch, if that makes sense. It's almost like it's built with its own off switch, and you rip off the on switch, and then it can be active. And then that one activates another one, and then that one activates another one. That's why we call it a cascade, is that you have a bunch of these clotting factors that each one activates the other by cutting it, right? So a protease is like a pair of molecular scissors, and you have this. And the idea of irreducible complexity, what Michael B. was talking about with that, is that how would you ever evolve that? Because if you're missing any one of the steps, you don't get a pathway. And having only the beginning or the end, you don't get that regulation of inactive form becomes active when you cut it, et cetera. So it's hard for it to envision it functioning if it didn't all come about at once. Well, there's two counters to this claim. First of all, the final product of that clotting cascade is a protein called fibrinogen, which when it gets cut becomes fibrin. And fibrin is the protein, the major component of a scab, or if it's an internal, it's a clot or a scab, just depends on if it's dry or wet. And the clot or the scab is made of fibrin, and also platelets and stuff like that. Well, fibrinogen, the full form of that protein, was found in starfish performing some other function. I don't even know what that is. But the idea is this was a co-opted protein. So a protein that was doing something else was there to be tooled around with when vertebrates started developing a closed circulatory system and all of that. That's one part of it. The other part of it is that the proteases themselves, these are the enzymes that this activates this, activates this, activates this, are very obviously duplicates of each other that have then evolved, slightly different structures and functions, but they're very clearly of the same evolutionary origin. So gene duplication created this cascade, and then evolution by natural selection, sorted it out. Now, here's the problem, and this is what Behe loves to exploit. Do we know every single step of the pathway of how it could have evolved? No, of course not. It's very hard to see earlier versions of this because everything alive today has the fully formed version. Ancestral organisms, even if we can find their anatomy, we're not going to find the blood clotting cascade, and we're certainly not going to find their genomes. So, so that's when you have to come up with schemes. And then you look for organisms that hopefully fill in the knowledge, and you make predictions. That's how science works, right? Is you say, okay, if this is true, then we would predict to see this, and then you go and look for that thing. So scientific theories make predictions that are testable. And in the case of the blood clotting cascade, but if you just Google blood clotting, evolution, that's probably enough. But then you can add in Russell Doolittle or Kenneth Miller. Those are the two that have written about it. Russell Doolittle was actually the scientist. Kenneth Miller, while he is a scientist, was writing about Doolittle's work, because Kenneth Miller works on the plants, I think, like chloroplasts or something like that. Anyway.
Okay. So
did a good job.
I wanted to ask. I was going to ask a different question, but somebody just put something in the chat at the very end, which I really think is interesting, as opposed to scientific thing. This is more of a philosophical thought. What do you think Darwin meant in the closing of Origin of the Species when he said, "There is grandeur in this view of life, with the several powers having been originally breathed by the Creator into the few forms into one, ... Was he religious at that point, thinking that he really thought there was a creation event?
So people have mused on that line and some others of his as well. Definitely the conflict between evolution and like his ideas and religious ideas was very palpable to him, and he stopped going to church later in life. And the time he wrote Descent of Man, I think he had evolved into an agnostic at that point. But the dominant sort of religious view at that time was among the elite was more of a deistic view, meaning a creator, sort of benevolent creator who didn't tinker very much. The whole blind watch, or the watchmaker analogy, or the divine watchmaker, where he sort of set things in motion, laws of physics, and so my thoughts about what Darwin meant by that was I think he was using a line that would have been pleasing to the deists who believed in God and believed that God set everything in motion, but he would have seen no reason for intervention at all. I don't know that he was an atheist by the time he died. I mean, I don't think he asserted a lack of belief in God, but I think he was pretty conflicted with the Church of England, for example, because, Archbishop, what was his name, Wilberforce or something, the Church of England was not happy about evolutionary theory at first, and so but I mean, the scientific community adopted it fairly quickly. It wasn't like he was a pariah. He was pretty popular, and but I think he means it the same way that Stephen Hawking meant it when he said, we will know the language of God. And I think God in that case is more of a concept of the beginning of the universe, origin of the universe, the way the universe works, laws of physics, laws of biology. I think that's a placeholder. And frankly, it's one that I don't think in and of itself does that much harm, to think that way. And but when you look at it in the context of the role of organized religion in society, then it's a little different. And I think that Darwin would have agreed with that. But no, I don't think he was religious by that point.
Thank you.
Well, that is, I think, a great stopping point. This has been so fascinating and educational. Thank you so much for sharing this. I'm going to have to look up a bunch of those resources you pointed us to, and we're going to share those in the show notes as well. But before we wrap up, is there anything else you want to mention, or any final thoughts that you want to leave us with?
Not really. I mean, I think I love the work that you guys are doing. It was a lonely path for me as well. I grew up very religious, in a religious home, and religious background. And I had a kind of the zeal of the convert when I left religion. I was very anti-religion for a long time. And that was when Dawkins and Hitchens and all those were at their peak. And I ate all that up. I've come to a softer view now. I mean, I don't, I have no religious inclinations, but I have more sympathy for the idea. I think that religion does serve a role in a lot of societies. And I think that atheism and secularism needs to keep in mind that we have to offer something positive in terms of community engagement and solidarity. I think solidarity is an underappreciated social construct. And I think that groups like this offer that the thing that you're missing when you leave religion is solidarity with people who have shared values and who care about issues also, because it's not just about, religion is not just about, their truth claims. It's also about the good that, at least with some of them, the good that they try to do in the world, and the good that they believe that they're doing in the world motivates them. They do think they're building a better world. And in some cases, they do it a lot of good. There are a lot of do-gooders in religious organizations. And so I think we have to be mindful about that as an alternative, that we should celebrate our shared values and don't just pretend, but really offer the world something better, or at least offer the world what they were getting from religion, which is solidarity and a sense of values and a sense of purpose, that we're going to act on it, and not because we think we're getting some magic reward at the end, but just because we want to see a better world, when we're gone.
So Nathan is going to be appearing at SciCon, so I'm going to put the link for the SciCon information and registration. And your talk is "The Future is Now, the Emerging Science of Human Improvement." That sounds fascinating.
Yes, I'm really excited for SciCon again this year. It's what, 3 years we haven't had it, so yeah, it's going to be great.
That is super exciting. And thank you so much for contributing your knowledge and, helping, get information out there to people who may have missed this information in school and want to learn more. That's also contributing to our community and doing good work in the world. So we definitely appreciate you coming and helping us out with that. And so
Pleasure.
thank you. All right. Well, we will be back again next week for another episode of RfRx. And spoiler alert, we're going to be debunking things again. We're going to continue the conversation about critical thinking with current skeptic and former ghost hunter, Kenny Biddle.
Woohoo.
Yes, and he will be discussing the application of skepticism to some of his past experiences and addressing those questions about things like belief in ghosts and the afterlife. So I am super excited for this. I know Rob is excited for this. So I hope we'll see
Absolutely.
y'all here
That
next
sounds
week.
so much fun.
Yes, please join us. Same bat time, same bat channel. And Rob, do you want to tell us more about where people can find previous recordings of our show?
I can do that. So Nathan, are you taking off now, or did you have some time to take questions directly from people? I forgot what time you said.
I can stick around for about 10 more minutes.
Okay, so we'll try to get through this quickly and maybe ask a few questions that way. Okay, so most of our previous RfRx recordings, there are 94 now, I just checked, can be found on our YouTube channel. And Kara's going to put that in the link. But more have been uploaded as audio podcast episodes because that's easier to edit audio than video. And so you can look at our podcast link to find those. We also have a blog, which was mentioned before, and that's a really good source of information. And as I said before, if you have any questions or comments or inquiries, you can email us at rfrx@recoveringfromreligion.org. And Kara, we have a whole bunch of social media you'd like to talk about, right?
Yes, of course. You know me. I love talking about the social medias. I use them so adeptly. I'm kidding, but we do have them and I am not in charge of them. So they work great and we would love for you to follow us on them. We are on the Facebook. We have a Facebook support group. We are on Twitter. We're on Instagram. We're on TikTok, and I'm dropping all of those links in the chat. And please feel free to follow us on whichever one of those platforms you use or all of those platforms. Like, subscribe, share, retweet, whatever it is that you do on there. It helps us reach more people and get more engagement, and that's a good thing. That helps us build our community, like Nathan was saying. So definitely check us out. And Rob, I hear there might be a newsletter.
There might be a newsletter. So it provides RfR's news, recently added resources, recently published videos, blog posts, that sort of thing. And you could find that at the bottom of our main page to request getting on the mailing list for the newsletter.
Awesome. Yeah. And as we wrap up, we're going to bring on Dr. Darrel Ray to give us some closing thoughts. But while we do that, we do want to hear from all of you about how you found the program this evening. So we're going to launch our feedback poll now. So please feel free to answer those questions about how you found us and what you liked and how it went for you this evening. And Dr. Ray, please take it away.
Thanks, Kara, and thank you, Nathan. This was really cool. I loved hearing all this. It was like almost yesterday that the Kitzmiller decision came out, and I thought, wow, I remember that. It was just so powerful, and I was so happy about it. And unfortunately, things haven't exactly gone the way I'd hoped they would after that. But anyway, it was fun to hear about that and hear your take on it. I sat down and did something crazy about 15 years ago, Nathan. I sat down and read Origin of the Species. I've been so deeply dove into biology and everything, but I'd really never read it before. And I don't encourage anybody to read it. It's pretty deep, but wow, what a genius. He just brought to me the amazing genius that Darwin had to put that all together. Anyway, have you ever read it to the actual Origin of Species yourself?
Yeah, I don't know that I've done the whole thing cover to cover, but I've done passages, and I did something that Ken Miller actually recommended and is to look at the different editions, because it came through, I don't know, 14 editions, 12 editions, something like that. And the first edition was the best. He stated things as strongly as he could, and then he got a lot of feedback and criticism, and he softened each edition. He really softened his claims and hedged a lot more. And remember that he was writing before. First of all, DNA hadn't even been discovered as a chemical. That was in the 1880s. That was in the 1880s. And its role in genetics wasn't appreciated until the 1920s. So he's writing a full generation or two before any understanding of genetics. So the idea that, so there was no mechanism, really. I mean, he talked about natural selection, but the mechanism of variation and change, they sort of thought everything got blended between two parents. And that's how offspring's genetics took shape, was just blending. And that really doesn't work. If you think about evolution, things would just diminish. You wouldn't have
they would devolve.
Yeah, for lack of a better word. And so you wouldn't have like the creative innovation, something like mutation, for example. Without knowing what DNA is, how do you ever even conceptualize what a mutation is? And so as he got criticism from scientists even, who were like, okay, well, why is there what mechanism could explain all of this? He softened it. And actually the latest versions are the weakest. If you look at his first edition, and you can find these online, first edition is the best. And so I'm not sure which edition you read, but I encourage you to.
I don't know what edition I read.
It's amazing to me too that he could do this without understanding what DNA is. And the same thing with the early genetics work that was done before we hadn't understood anything about how DNA worked. The fact that we could learn all this about inheritance is pretty incredible.
Yeah, I'd say the bottom line for me wasn't whether he was totally right or totally accurate or all that. It was that he had this incredible ability to take so many different aspects and observations and facts and put them into a theory that really, really worked. Yeah. But anyway, thanks so much for coming. And man, Karen, we should try to find out if we can get him back for some other aspect of this.
I'm working on a new book, so when the new book comes out, I'll let you know.
We would be glad to help you publicize your new book. And I was watching the discussion. There were lots of interaction, discussion. So you really engaged our audience. I will personally recommend The Ancestor's Tale. I thought it was I also love anything RfR did, for those of you who are interested and want to just watch YouTube stuff. Also, Carl Zimmer's stuff I find very well written at a layperson's level. He's got a book out called She Has Her Mother's Laugh that really explains genetics a lot better than I think about any other science writer has. Carl Zimmer's science writer is not a scientist, but
yeah, I actually used that text in my genetics class because I think he covers the history of genetics too in a way that a lot of scientists and geneticists, we like to bury the origin of our discipline because it's not flattering.
Oh yeah, you're right. He has some bad case studies, or some case studies that would be
No, I think we have to confront that history. It's the same thing with this country, but genetics is the same way. We really have to confront that past and that history. And I wrote an essay, it never got published, about how I said, I believe in original sin. And the reason, but I believe that the foundation of a lot of our most cherished institutions were founded on some real horrors. Like the United States was, our original sin between the indigenous people and the African slave trade, we are built on atrocities. That's the origin of this country. And genetics is the same way. Genetics was born of some really nasty stuff.
Yeah.
So I think that laboring against that original sin should be our life's work. Anyway.
Good.
I never got that article published.
That might be one you'll never get published.